Hello everyone, I Syed Nawaz. I welcome back you to my YouTube channel Math World. So today I'm back with a new video on a numerical problem which appears in GATE 2017. This problem is related to directional drilling and we have some nice calculation in it. So without wasting a time, just quickly we'll see the question. The question is, in a directional drilling well, the kickoff point has a true vertical depth, which means a TVD of 1000 meters, and the end of build-up section has a TVD of 1200 meters. The build-up section for a directional drilling has an horizontal displacement of 200 meters, after which the tangent section has inclination of 45 degrees. A driller monitors the well from the surface location of the well and sees that the horizontal departure of 1000 meters. So finally we have to find the TVD, means the true vertical depth of the point of the well, of the deepest point of the well, you can say. Although I didn't wrote deep here. The deepest point of the well in meters. So if you just know the simple mathematics and if you have a simple knowledge of directional drilling, then you can easily solve this 2 marks question. As you can see, the question can be represented in pictorial way like this. Like I have a kickoff point over here and build up section up to here, and I have an horizontal displacement, and after this build-up section, as he wrote in the question, that after which the tangent section has an inclination of 45 degrees. So from here I made an as you can say, as he mentioned here, the inclination of 45 degrees, but it is nothing but a tangent zone, if we call in directional drilling terminology. Okay, so let us quickly see what will be the answer for this. So he is asking to find the total TVD. So from this point up to this point. So let us see with the representation over here. So this is nothing but your problem. So first I wrote the given data. Given data is nothing but kickoff point he has given in the question as 1000 meters. Right. So I represented here the kickoff point as P to Q. Okay, and the build up section data he has given as horizontal section, means the horizontal section what I represent here as x dash to r. Horizontal section is nothing but 200 meters and TVD is 1200 meters. So the TVD for this horizontal displacement is nothing but from P to x, from P to x dash. So firstly, as I already wrote here 200, but if you have to find the distance from P to y, then you have to first find the distance from Q to x dash, then you have to find the distance from x dash to y dash, right? So right, we'll see the next point. The horizontal displacement is nothing but 1000 meters. So the horizontal displacement what I represent here as y dash to s is 1000 meters. Okay, so hope you understand the question, and he has given the inclination as 45 degrees after the end of build up section. Now let us see the calculation. So first I need to find the calculation of q to x dash. So to q to x dash, if you see the simple calculation, it will be like from the distance from P to X dash, what he has given in the question as horizontal section of TVD section of build up is 1200 meters minus the PQ, which is nothing but a kickoff point section TVD. Okay, so what I wrote just formula here is distance QX dash is equal to build up TVD section minus kickoff point. So I'm just substituting the value. The build up section TVD section is 1200 meters and kickoff point is at 1000 meters. Okay, after simplifying this, I'm getting the answer as 200 meters. What I just wrote here, the distance of Q to X dash is nothing but your 200 meters. Then after that, if you see, he is also giving he has also given in the question that the horizontal section is nothing but a 200 meters. So here the horizontal section for 200 meters is for build-up section. So the build-up section ends at a point R, okay, and from X dash to R the distance is 200 meters. Why we are specifying this, I am going to tell you in the next step. Okay, so as finally in the second step we are going to find the distance of TS. So where is T? Here the point exactly parallel to R. I am just representing this point as in T, because I have when I have to calculate this point R to T, so I should know the point T to S, and I have a 45-degree inclination. So by using tan theta formula I can just simplify it, the distance between distance of RT, which is exactly parallel to X dash to Y dash. Okay, so if I have this value, then I can simply calculate the total length from P to Y dash, which is nothing but your deepest point TVD. Okay, so here I am calculating the value of TS. So as I mentioned here, the value of X dash to R is nothing but 200 meters. So you can see as they are parallel to each other, so the distance will be same for them. So the distance from Y dash to T will be 200 meters. As the total distance is 1000 meters, so we just have to uh, take a difference of Y to S minus Y to T. Okay, so what I wrote over here is distance TS is equal to horizontal displacement, what I represent here as Y dash to S, minus the distance of R to X dash. Okay, R to X dash, or you can also write T to Y dash. So the values are nothing but 1000 meters minus 200 meters. After simplifying this simple calculation, I got the answer as 800 meters. Okay, hope you understood this one. So we'll jump to the next section, in which we have to find the distance of R to T, which is exactly parallel to X dash to Y dash, right? So what I wrote here is distance of X dash to Y dash, or R to T. So if you take up this section separately, as what I did over here, I took this section separately and draw over here, and I got the value for T to S as 800 meters, and I have an inclination of 45 degrees. So as we all know that tan theta equal to opposite by adjacent. So theta is nothing but 45 degrees here, and opposite is RT, by adjacent is TS. So as we all know that tan 45 will be equal to 1, then RT, we have to find the distance of RT, then TS, uh, what we have calculated just before from horizontal displacement, is nothing but 800 meters. So 1 equal to RT by 800. So simply I got the answer as RT equal to 800. Then finally what we have to find is the total distance of the total TVD. So the total TVD I can represent over here as you can see in this figure, it is coming from P to Y dash. Okay, it is coming from P to Y dash. So if you just divide this section, what we have calculated, so it will come from P to Q 1.1 distance, and from Q to X dash will be one distance, and X dash to Y dash will be another distance. Okay, so I simply wrote whatever I said the same here. So Py dash is equal to PQ, this is nothing but your kickoff point, plus Qx dash, this is nothing but your build-up section, and finally after the build-up section, the point up, the TVD up to horizontal deepest point, okay, which is nothing but X dash to Y dash, right? So I am just simplifying this. I have substituted the value PQ is equal to 1000 meter, which is given in the question, and Qx dash, we have calculated this, it is nothing but 200 meters, and finally X dash Y dash is equal to 800 meters, what we have calculated over here and represented as RT, and I said you that RT is exactly parallel to X dash and Y dash. So after simplifying this, I got the answer as Py dash is equal to 2000 meters. Okay, so This is an end of a numerical problem, but let us see after finding this all values what will be our pictorial view of that question. So this is nothing but your kickoff point, which is nothing but PQ is equal to 1000 meters, and up to end of build-up section is 200 meter, and horizontal displacement is also 200 meter, which is given in the question, right? So from x dash to y dash it is 800 meters, and the total distance is 2000 meters. That's a simple end of this question. So hope you like this video. If you do so, then hit like, share, comment and subscribe, and hit the bell icon to get a notification of for all my new videos. So thank you so much. We'll meet in next video with a new problem. Have a nice day. Bye bye.